Okay, this is question number 1, easy level. This has to do with method of substitution. The question says evaluate the indefinite integral using substitution. So here we've got indefinite integral notation right here. We've got some function that looks quite complex. You can notice that it consists of two chunks multiplied. Method of substitution is basically trying to spot some kind of a chain rule that takes place within the given integral expression, separating this whole expression into something in the form of something in the form of like f at g at x, and then some other component that takes the form of g at x. Obviously, these two will be related. The key is to spot that. Substitute g at x as a simpler variable called u. So in this case, this is easy level because it's quite easy to spot this. And for some of you who are so advanced and so experienced in taking these integrals, you don't even have to use substitution. Because we are in this section learning about substitution, trying to go from easy questions to a bit more complex questions, let's tackle these questions. Let u be this. We don't have to bother with the square root. Square root can be part of this big f. We're just interested in g at x because then g prime x, which is the first derivative, takes the form of this. You can see that 2x to the power of 2, derivative taken would be 4x, and minus 3x will be this minus 3 right here. It's pretty straightforward here. So let u be something inside the square root. So it's going to be 7 minus 3x plus 2x to the power of 2. Then we take du, which will correspond to the derivative of u. So obviously it's g at x. And this is not a complex function, so we just end right here. Du is equal to, we can rearrange. So this will be 3 and then plus 4x. And we've got dx because we're taking derivative of u with respect to x. So we've got this dx taking place here. To rearrange, we have 4x minus 3, rearranging so that it looks identical to what's inside the question. This will equal to indefinite integral square root u, and this whole thing is now equal to du. So we can just say du. It's much simpler. For those of you who are not familiar with working with square root, just basically that's u to the power of 1 over 2 and du. Now then it's going to be u taking antiderivative, taking that into the denominator. So we've got 1 over 2 plus 1. And because we are dealing with indefinite integral, we have to make sure that we cover all the families that are represented by this integral. We have to add the constant factor of c. The rest is just simplifying this. So we've got u 3 over 2. And this is 3 over 2. So when that gets brought up, it's going to be 2 over 3 u to the power of 3 over 2. My apologies, we have to continue to put plus c, and we have to say plus c. So it's really easy to forget that. Now we have to substitute back in our original variable x because that was how we started off. We can't just end here. We use this method for easier computation, but we have to plug back in the variable x. We say 2 over 3. U was equal to this, so we just put 7 minus 3x plus 2x to the power of 2, and the whole thing raised to 3 over 2 plus c, and that is our final answer. For those of you who want to change this fraction power into like a square root and then the whole thing bracket to the power of 3, you can do so, but it's sufficient to leave it as it is. If you want to make sure that you got the right answer, then you can just double check by taking the derivative of this. In this case, this will come to the front, this will cancel out, this power we subtracted off by 1, we're left with 1 over 2, which is converted to square root signs. And then taking chain rule, so inside function will come out as 4x minus 3, so it matches exactly to our initial question. So when working with method of substitution, scan through this given expression and see, that it follows some kind of a chain rule form, and then spot what g at x is and let that equal to u. Derivative of u with respect to x is simply derivative of this inner function, which is g prime x. And then the rest work with the computation, and remember to put the constant factor when it comes to indefinite integral and substitute back in the original expression to where u is.